Hi friends, welcome to FoxuTech. Today we're going to see about Kubernetes Autoscaling. And in this, we're going to see what is autoscaling and what is Kubernetes Autoscaling and what are the methods it provides. And also we're going to see why we need autoscaling in Kubernetes and the limitation on the autoscaling methods, what are available. And also we're going to see the best practice we should follow, right? So let's jump into this. And let's start with what is autoscaling first of all. So autoscaling is nothing but it's just a computational dynamically if you want to manage your environment. So autoscaling is one of the key tool for that. Let's say whenever there is a CPU spike or memory spike or there is a more number of incoming traffics, you need to automate, you need to scale your applications, right? That is most important if you are promised to deliver the high available instances, right? So how you can achieve, so we can't sit in front of the system and we can't monitor 24/7, right? So we have things to do our own. So instead of that, there is a technique which help us to do it automatically. It can decide based on the threshold, whatever you set, it take a decision and it take action on it, right? So that's called like auto scaling. And what are the things it can do, right? So it can help you to do various things. One is like a decreasing the number of pods or the nodes whenever there is a load is low, right? So it's unnecessarily resources may be consumed, so we don't need to have it the pod or node to be running automatically or unnecessarily, right? And also whenever there is a spike in your network or the traffic is coming up, automatically your application should scaled up, so your users won't be affected with any other downtimes, right? And what are the advantages it provides if you ask? Yes, it gives a various advantages. First thing is like a costing. So costing is very much important for IT world because we are provisioning n number of resources currently, but are we tracking? No, right? If you've seen our costing session on last video, so you may understand how much we are wasting the resources. The world, IT world is, we are just living up to that, and there is a things coming on to optimize this, but it's how efficiently we are doing. It's always question mark, right? So this kind of technology will help us to maintain everything automatically, and we can save a lot of cost. Second thing, so increasing the uptime for your application, which is very much important if you are serving for the customers. So it is very, very much important. So let's say like your provision application with 1,000 users and unexpectedly there is a 2,000 users are onboarded. What happens, right? So we will be, the customer will be lagged and our service will be questioned on that place. So to avoid all this, so this kind of technology will help. And also, so as you said, so you want to enable like a scale it immediately. So if you have like a 2 GB of RAM and you want to have one pod and you want to scale it to multiple pods, so you need to do everything manually running it. And sometimes the command may be easy to type, or you may forget, or you are not handled with the command, the manifest, whatever we have, right? So on that, to avoid all these scenarios, if you can automate everything to tools like this, so that will help us to just scale it up in a seconds and we will be good on that, right? Well, so this is about auto scaling. So let's see what is Kubernetes auto scaling and what are the methods it provides. Kubernetes auto scaling, it started from the version 1.3. So it's been a while, it's available in the market. And when we talk about auto scaling in the Kubernetes, we are not speaking about like a number of nodes or any other deployments or stateful set. At last, everything is a pod, and here everything is like a replicas, number of replicas of pods, how many you are increasing and how many is decreasing, right? So that is mostly on that. And how you do this again. So it's based on the method, whatever the Kubernetes autoscaling is providing. So let's see one by one methods, what all it's providing. The first method we're going to see is horizontal pod autoscaler, which is called in short HPA. So this is how it's look like. So any autoscaler or any autoscaling in Kubernetes, it's required a metric server to collect what is happening on your particular pod or particular node, right? Particular deployments. So it need to be stored in the metric server, and the metric server will give you the enough details to the autoscaler. Okay, so first the metric server provides regular updates to the HPA or horizontal pod scaler, and it's check is there any CPU or memory or incoming traffic, whatever you define. It's keep track. The defined values are beyond the thresholds, right? Immediately this autoscaler thinks, okay, there is something is spiking up, so I need to take action. So the action is nothing but scale the number of pods, right? So it's whenever there is a high spike, immediately it scales up and the number of pods will be increased. Let's say you have started your deployment with one pod, and then you have seen like a multiple requests are coming up. So now you want to scale it up, right? So how it does? So automatically this will take care, and this will be, so automatically your pod will be started scaling up. It's not a one-time work. It's regularly it's going to do whatever the defined in your manifest, the HPA manifest, how many pods you are asking to replicate. So it will keep replicate and it will set the numbers. So this doesn't need any kind of a downtime, please be noted. So this is a key advantage about horizontal pod scaler, right? But there is a next one is called vertical pod scaler. What vertical pod scaler does, the almost similar way, like whatever the pod it has, it just monitors from the metric server and it's collect the utilization. And if there is a change spike on either a memory or a CPU, so here what it does, it's going to update your memories or the CPUs if the respective node has enough memories, right? So it's going to update your deployment file, and from the deployment file, your number of the pods will be updated. But here the problem is whenever there is a change, it's applies and it restarts. Obviously, you know that existing pod, if you are making any change, obviously it has to be restarted, right? So here, at least you need to have more than one pods replica existing. Otherwise, your application will be down, and when it's coming up, at least you may see even 1 minute of time or 2 minutes of time. Even it matters when it's like a SLAs, SLIs, if you calculate that even matters. So here again, so you need to consider this whenever very much needed, then only you have to choose this, or you have to, it's up to you. Again, there is a drawback. It restarts your pod and your application will not available when the pod is restarting, right? So be aware of this while you're choosing a perfect autoscaler. Okay. Next, cluster autoscaler. So now we are seeing two things. One is like a vertical and horizontal, which is mostly focusing on the pod. But here we're gonna see like a cluster autoscaler, which is nothing but number of nodes, right? So this should be on either cloud, AWS or Azure or GKE, or wherever the cluster Kubernetes provider, managed Kubernetes provider should support this kind of features. So when you choose your Kubernetes managed Kubernetes service, please be noted this is available. And why this is available important? Again, let's see that. So let's assume like you have two nodes and both the nodes having high memory utilization and high CPU utilization, and obviously there is nothing to do. So even you can do the horizontal pod scaling because already your node are even full, or you can do the vertical also do that. What you have to do? So the next work is you want to increase the number of nodes, right? From 2 to at least 3 or 4. So how it happens? This cluster autoscaler keep monitor your pods, and if there is a more than certain numbers of pods still waiting for a node, then it's a request to the cloud provider and it's get created new nodes. Okay, the new nodes, once it created, automatically the pods will be scheduled to the new node. You can see it here. So already the request, it passes and the new node will be created over here, right? So this is what the moreover the functional aspects we'll see in dedicated videos for each auto scaling type and how it works, how you can configure it on our further sessions. Okay. So next, why we need auto scaling here? Again, as I said, first thing is high availability. So whenever we are running any application, we can't predict, right? So the first thing we have to acknowledge is we can't predict this is what my application capable of, or we can't definitely say this many users only use my application, right? It's hard to define. If your service is very well and good, obviously there is a more number of users will be popping up to your platform and you're gonna use it. They're gonna use it your application very robustly, right? On that time, let's say like you deployed application for 100 users and there is 100 users are already using, unexpectedly or your application is getting famous and you are getting your new requests. So what happens when you get the new request? Obviously the number of loads will be increased. So number of loads will increase 100 to let's say 200. It's almost 10x or the 2x, right? So now what happens? Your application pod try to sustain still 140 requests or 150 requests, but beyond that your application will be started struggling. Either it may be a spikes to memory or spike to CPUs, right? So those kind of issues will come. So to avoid such a things, the auto scaling is a very much important. Okay, so you no need to sit in front of the system 24/7 or triggering some kind of a fancy alerts and do all the steps by manually. That is not needed, as this tool is very much capable to handle that. It can just scale your number of nodes or number of pods automatically, right? So that is very much important. So as per the survey, there is a almost this year there is a 30% of users going to migrate to the microservices world. So when you migrate, if you are still migrating phase, please consider this for your application given. That is pretty much important, right? Next. So when we speak about the advantage or the tools, there will be limitations. What is the limitation here? So let's say like you are trying to choose either HPA or VPA are chosen. So there is again your application is having a restriction, or your application is not a CPU intensive, or it's not a memory intensive. It's a moreover like a storage aspect, like IOPS intensive, right? It's need a high number of input and outputs for operations. So that that will be a key problem, like your storage or it may be a network, either way, right? So with that, is there any possibility to auto scale? No, at this moment there is none of the auto scaling options from the day one, like last 10 years or 15 years, there is no option to scale it when you have like a more IOPS. So why? Because like sometimes the IOPS will be indirectly trigger the scale your CPUs or memories. But if your application having enough CPUs and memories, but still it's struggling to give the IOPS, then your application will perform very slow and users will be affected, right? So that will be affect your business also. That is on the HPA and VBA. And next is like autoscaler. Again, the cluster autoscaler is very much limited because your Kubernetes platform should support the autoscaling. Okay. And again, this just blindly say the pod is waiting or the pod request, and it's not actually maybe a reason the pod is pending state, not only for the node. There is a multiple reasons. There could be some other issues. Even if there is a numbers are high, and if you are not planned your pod is not perfectly designed, that may also happen, and automatically you make provision with the multiple nodes and you end up with paying unnecessary amounts. So always there will be a limitation. So we have to plan our infrastructure or the application wisely, and we have to configure it with the perfect numbers, or at least not perfect number. Again, we can't decide the perfect number always. So what we have to do, so we have to find a approximate number what we can reach at least. So that will help us to save our environment by 80 to 90%. Remaining 10%, there will be a plus or minus always, so that we can learn it from our experience and we can improvise it slowly, right? So these are the limitation on the auto scaling aspects from the Kubernetes side. And next thing is like a best practices. So what is the best practice we should follow here? So always make sure you are not conflicting with your HPA and VBA configuration. So choose wisely, because HPA will be scaling your pod and VBA is focused only for the restarting or the increasing the CPUs. So if there is both are happening together, then you are again end up with paying a number of monies. So don't waste it otherwise. And also if you have both, at times your application may go down, again your application SLA will be high. So that should not be always correct. You should always keep your SLAs limited, and it should be always like 99.59999 less than that. Okay, so always keep it 99.5 in the Kubernetes world. It's possible. So it's everything comes together when you are planning your complete infrastructure wisely, right? So next, always try to use your instance weight score. What is weight score here? So weight score is nothing but it's simply you can't decide like a CPU spiking and I can increase it, right? So that may happen even if you are not chosen your cloud instance properly. So you have chosen an instance from AWS or Azure or EDC or any respective cloud. So you have to check the numbers, weight score, and then you have to choose it, because they may say like we are providing 8 GB of RAM, but not always it's correct. Okay, sometimes the usable memories will be like a 6.8, 6.9. In that case, so you will be stuck. So you may think like, hey, I have 8 GB instance, it can sustain for 8 GB, but it not all the time the case. There will be a hurdle. So you have to understand that, and you should implement, you have to choose your base instance very much wisely. Okay, check all the aspects, how many CPU you want it's providing, you have to calculate, and how much can be used also you have to check. So right, so even for the storage or the network input and throughputs, always choose. So you may have seen when you are choosing instance on the AWS or Azure, so they may give the list, they list it down what is available memory and what, but not always they give what are usable memories. Okay, that you have to understand and you have to use it very much carefully. Okay, because auto scaling may be decided like blindly it may choose. Let's say like you are having a, let's say you have chose like a cluster autoscaler with a single instance type and the cluster type, and you have chosen a 2 GB, 2 CPU and 8 GB RAM, right? But unfortunately, the instance can serve only 7 GB of RAM, 2 CPUs or 1.9 CPUs. Your application always expecting certain numbers, like it should be 1.8 or 2 GB of RAM and 8 GB of RAM or 6 GB of RAM, and you are unfortunately enabled a cluster autoscaler with HPA, number of pods. Only one pod will run it on one instance. You are running a one pod per instance at last, and you are paying end up with multiple nodes and multiple pods, right? So those kind of issues you should avoid by choosing it with a weighted score. So next, always go with the mixed instance. Don't choose like hey, I have autoscaler and let me go with the default template. Let's have my all the instance can, let's have like a 10 GB, 10 CPU and 50 GB of RAM, right? That's not a correct way to do it or handle it. Always go with the mixed one. Let's say like a one instance, you can say like a 10 CPUs and 50 GB, and other instance can be 8 CPUs and 40 GB RAM. Like that, you can choose with a multiple, because whenever there is a Kubernetes has a facilities, and even in the cloud, autoscaling and autoscalers have a facilities like if you are if your number of instance won't be counted like a number of resource utilization. If one node is like a completely not used, so it's automatically going to be drained down, right? So when it's drained down, let's say like you are having a small nodes and that is all consumed, and then it's going for the big nodes. So your large node will be shut down, or it won't be in the all the times in use. So you will be saving again one much number of cost. Okay. So cluster autoscaler, it supports this multi-mixed instance type also. You have to define it properly. So with that, what you can get advantage, the mixed instances will save us a lot of again money, and that will be saved our availability, sorry, application downtime also won't be occur. Okay. So if you ask me which is the best one out of three, again, it cannot be answered very straightforward. You have to choose your application wisely, and you have to understand your application wisely, and then you have to decide it. Okay, this is what I'm going to do it. Okay, this tutorial is just give you the hints like what is autoscaler, horizontal autoscaler, vertical autoscaler, and cluster autoscaler, and you have to find your own use case and decide which one is you can use it. Okay, hope this video is useful, guys. If you like, please hit like and subscribe and share it with your friend, and we'll see it on the next videos about each and every autoscalers, and we'll explain how to configure. We'll also demonstrate how that can be done, right? Thank you guys again. Thanks for your time. Have a great day. Bye bye.